In this next section of 2.1, we're going to look at quadratics and cubics using function notation. So this is going to be really good practice for actually the next section of our notes, and it's just a good reminder of how we use function notation with two new types of functions. So for this first set of problems, I have f of x equals 2x squared plus 3, and I want to evaluate each function and simplify my answers as completely as possible. So for f of -1, I notice that -1 is inside the parentheses, just like the x is here. So as a reminder, -1 is an input, meaning that in this function, wherever I see the variable x, I'm going to replace it with -1 instead. Now I just have to remember order of operations in order to simplify this expression. So when I think about order of operations, the first thing I work with is my exponent. I know that -1 squared is +1. So I really have 2 times +1 plus 3. Then I multiply and add. 2 times +1 is 2 plus 3 is 5. So a really nice looking answer would look something like f of -1 equals 5. That way I can see both the input, what we plugged in is -1, and the output, what we got for our answer was 5. For the next one, f of the square root of 7. Again, the square root of 7 is an input, so 2 times the square root of 7 squared plus 3. Again, thinking about order of operations, I'm going to start by squaring the square root of 7. Now, when I think to myself, I don't really know what the square root of 7 actually equals, but I don't need to when I'm squaring it. There are a couple of different ways I can think about this. When I square a number, that means multiply by itself. So really, I've got the square root of 7 times the square root of 7. When we multiply radicals, as a review from Algebra 1, we can just multiply the radicands since we both have square roots. 7 times 7 is 49, and I know the square root of 49 is 7. The other way we could have thought about that, square roots and squares are inverses of each other. It's an opposite operation. So square root and squared are going to undo each other, leaving us with just the number 7. So all that to say, when I square the square root of 7, I just get the number 7. So 2 times 7 plus 3 would be 14 plus 3, 17. For the next two, I'm plugging in variables for my function. So when I plug in 2x, instead of this 1x, I'm going to replace it with 2x. Okay. Thinking kind of back to our previous example, if I want to square the 2x, that's 2x times 2x. 2 times 2 is 4, and x times x is x squared. So instead of 2x quantity squared, I really have 2 times 4x squared plus 3. 2 times 4x squared is 8x squared. And since those are not like terms, that's my final answer. So f of 2x equals 8x squared plus 3. Okay, and I should actually go back and fix this first one. F of square root of 7 equals 17. Okay, and lastly, for this f of x function, I'm now plugging in x plus 1. So 2 times x plus 1 squared plus 3. Again, if I wanted to do my work to show x plus 1 multiplied by itself, I can think off to the side here. When we have x plus 1 squared, we're multiplying x plus 1 by itself. I never want to see you just distribute that squared to the inside of the parentheses when we see a plus or minus separating terms. We have to multiply x plus 1 by itself. So this is a good review from Algebra 1 where we distribute. I want to multiply first x times x to give me x squared. X times 1 will give me 1x. Then I move on to this 1. 1 times x is also 1x, and 1 times 1 is positive 1. So now here I have like terms that I can combine. X squared does not have a like term, but 1x and 1x, when combined, give me 2x. So now when I go back and finish the problem, I've got 2 times x squared plus 2x plus 1 with the plus 3 on the outside. I can go ahead and now distribute the 2, and get 2x squared plus 4x plus 2 plus 3. And then lastly, I notice that this 2 and 3 are also like terms. So I get 2x squared plus 4x plus 5. So notice that when we plugged in expressions with x, we also got expressions with x out. Let me fix this box. Okay. For our next example, we have a new function g of x equals x cubed minus x. And again, we want to evaluate the function and simplify our answers. I notice that this function is different because it's a cubic function. The highest degree we see there is a 3. So similar types of problems. The first one, I want to plug in the number -2. This time I have x in 2 separate places, so I replaced that x with the number -2 both times. Okay, so now I'm just going to evaluate. So working with my exponent first, -2 to the third, or -2 times itself 3 times, is -8 minus -2. I can simplify this minus negative and turn it just into a plus. And I know that -8 plus 2 is -6. For the next problem, I'm going to plug in the number 1. So 1 cubed minus 1. 1 cubed is 1 times itself 3 times, which is still 1. And 1 minus 1 is 0. Again, down here now we have some expressions that we're working with. If I plug in 2a wherever I see an x, I've got 2a cubed minus 2a. Remembering kind of what we did in our last problem, 2a cubed means 2a times 2a times 2a. I know that 2 times 2 times 2 is 8, and a times a times a is a cubed minus 2a. Those are not like terms. A cubed and a cannot be combined together, so I'm going to leave it just as is. All right, then lastly, my next input, oh boy. Sorry about that. You just saw all sorts of things on my background. I hope you really enjoyed that picture of my beautiful family. My next input is -3t squared. So I'm going to, wherever I see the x, plug in -3t squared. Okay. I'll use the similar idea of what I did in the previous problem. If I wanted to cube this -3t squared, that means I'm multiplying -3t squared by itself 3 times. So to simplify this process a little bit, notice here in the first problem, when I had 2 cubed, I just multiplied 2 by itself 3 times. And when I had a cubed, well, that just turned into a cubed down here. So let's look here. -3 cubed is going to be -27. And t squared cubed, if we remember our exponent rules, it's actually going to turn into t to the 6th. When you have a power to a power, those two numbers multiply together. The minus and the negative here, the only thing we can do to simplify that is turn it into a plus. And again, they are not like terms, so we cannot actually combine them. I want to take a second and point out a big difference, though, between this problem and the problem we did up here for f of x plus 1. I told you in this problem that I never want to see you distribute that exponent, but down here it kind of looks like I just distributed the exponent. The big difference in these two problems is this plus sign. When we have a plus sign and an exponent on the outside, plus or minus sign, we are not allowed to distribute the exponent. In this problem down here, though, there was no plus or minus sign in between the -3 and the t squared, so I could distribute that cubed.